Hi. After estimating univariable logistic regression function in video number 562 and 563, in this video I am going to estimate and interpret multivariable binary logistic regression in R. And in this regression, in this logistic regression model, I'll be regressing heart disease on 4 other variables, 2 of which will be categorical and 2 of them will be numeric or quantitative. The main advantages of using a multivariable logistic regression model compared to a univariable logistic regression model are to consider the simultaneous effect of independent variables, taking into account potential confounding and interaction effects, and improve predictions. For this illustration, suppose we would like to estimate the relationship between heart disease and all other variables which are present in this data frame, that is age, sex, chest pain type, and maximum heart rate achieved. We will use the following type of model, and I'll call this model as M3. I have already estimated M1 and M2. M1 was a univariable logistic regression model in which the dependent variable was heart disease, but the independent variable was quantitative, and that was age. In M2 model, the dependent variable was heart disease, but the independent variable was categorical, and that was gender, that is male female. In this model, I am regressing heart disease on 4 variables, and I am using this command glm heart disease followed by tilde and then this dot, and data is equal to data, and family is binomial. So let us see how we interpret these results. So let me start with regressing this model. As I mentioned earlier, M3 is my model that I am just going to estimate. Let me click, and now I will show summary results of this model. Now if you look at the estimated coefficients of this model, the coefficient of the intercept or constant is minus 0.06. The estimated coefficient for the age is 0.04, and the estimated coefficient of the gender coefficient is 1.6 for male. Similarly, these are 3 coefficients for chest pain, atypical chest pain, non-anginal chest pain, asymptotic, and finally the coefficient for the maximum heart rate is also there. Now if you look at the p-values, so the coefficient of age, the coefficient of gender, the coefficient for the asymptotic type of chest pain, and that of maximum heart rate are significant at 5% level. Now I want to level the chest pain. So on the basis of the coefficient result, we conclude that at the 5% significance level, age, sex, and maximum heart rate achieved are all significantly associated with the heart disease, where p-value is less than 0.05. After that, I'll give this command level chest pain, and if I do that, the first one is typical angina, second one is atypical angina, and third one is non-anginal, and fourth one is asymptotic pain. So it will take the first one as a base category. After that, to test the overall effect of chest pain on heart disease, we are going to compare 2 models via likelihood ratio test. A model which includes all the variables of interest and the variable chest pain, and the exact same model but which excludes the variable chest pain. So the first the first model is referred to as the full model or complete model, whereas the second model is known as the reduced model. And we will compare the two models with ANOVA functions. So let first me estimate the reduced form of the model, in which there are three variables: age, sex, maximum heart rate, but it excludes chest pain categories. So if I hit run, it will this model has been now estimated. Now I will run ANOVA test for this model based on likelihood ratio test. Now this test has been computed, and the null hypothesis of this test is that the two models are equivalent. However, if you look at the p-value, the observed p-value, so at the 5% significance level, if we see the p-value, we reject the null hypothesis and we conclude that the complete model is significantly better than the reduced model at explaining the presence of heart disease. This means that the chest pain is significantly associated with the heart diseases, which was expected since the comparison between typical angina and asymptotic was found to be significant. Now that we have shown that all four variables are significantly associated with the presence of heart disease, we can interpret the coefficients in order to know the direction of the relationships, and more importantly, to quantify the strength of these relationships. Just like univariable binary logistic regression, it is easier to interpret these relationships through odd ratios, but this time we also print the 95% confidence interval of the odd ratios in addition to the odd ratio rounded to 3 decimals, so that we can easily see which ones are significantly different from 1. Now, in order to do that, I am using this formula, and this will compute the coefficients along with the odd ratios, and followed by 95% confidence interval. So let me hit run, and here I see these are odd ratios for the various variables. This odd ratio is for age, this for sex male, this is 5.4. These are other odd ratios for this. Now from the odd ratios and their 95% confidence computed, we conclude that regarding age, the odds of having a heart disease are multiplied by a factor of 1.044 for each 1 unit increase in the age, everything else remaining the same. Similarly, regarding the sex variable, the odds of developing a heart disease for males are 5.4 times the odds for females, all else being equal. Regarding the chest pain, the odds of developing a heart disease for people suffering from chest pain of the type asymptotic are 7.13 times the odds for people suffering from chest pain of the type typical angina, all else being equal. However, we will refrain from interpreting the other comparison as they are not significant at 5% level of significance. After that, suppose that now I would like to predict the probability that a new patient develops a heart disease. Suppose that this person is 32 years old, and she is a woman, and she is suffering from chest pain of the type non-anginal, and she has achieved a maximum heart rate of 150. Then the probability that she develops a heart disease is can be predicted by this function. So this is new patient. I give new patient to this data frame. Age is 32. She is female, and she is suffering from non-anginal pain, and her maximum heart rate is 150. So let me click run. Now this model has been estimated. I will now predict the probabilities, and after that I will see the prediction. So here is the prediction. you see the prediction is 0.033. Now if you trust this model, the probability that this new patient will develop a heart disease is predicted by 3.35%. Now let us suppose I change some of the values in this model, and instead of 34 years women, I am using a male of 50 years. So his age is 50 years, male, and he is suffering from non-aginal pain and a maximum rate of 150. So if I hit run, it will estimate this new patient 1. After this, I'll predict the probability of this 50 years old male having non-anginal pain and a maximum heart rate of 150, and after that I'll predict the probability that this new patient that I call new patient 1, who is 50 years of age, and he is suffering from non-anginal pain, and he has maximum heart rate of 150. So the probability is now 0.287. So it means that if we trust our model, the probability that this new patient with age 50 years, male with non-anginal chest pain and having a maximum rate of 150 will develop a heart disease which is predicted by 8.77%. So this probability is higher as compared to the previous one, that was something it was around about 3.35%, and this one is 8.77%. My dear students, my dear colleagues, my dear friends, this is how we can predict probabilities using multivariable logistic regression function in R. It's very useful, and you may use same kind of methodology for analyzing your data, your own data set, and then you can interpret the results. I hope you enjoyed the video, and I would like you to share this video with your colleagues, with your friends, with students, and in various WhatsApp groups, so that this could reach to the maximum possible number of people. Kindly don't forget to subscribe to the channel, and don't forget also to click on the bell icon so that you can get timely notifications about my other videos that I'll upload.